Okay, so Alan, what do you have here?
We have a setup for crosstalk to measure crosstalk on an ISL54405 eval board. We have the eval board shown here. We have the audio precision generator that we're going to use shown here. You have the signal side of the generator. You have the analyzer side of the generator. We've got a 3.3 volt power supply that's coming down and connected to our 3.3 volt pin. We have our GUI for the audio precision, and we're showing the setup right now that you have to measure crosstalk. So here's the setup for your signal generator, here's the setup for your analyzer, for your sweep, and there's an actual measured sweep of crosstalk over frequency from 20 hertz to 20 kilohertz.
Okay, and then...
Did you pause it?
No, let's keep running it.
Okay.
If you look at the application block diagram, you want to talk about it a little bit?
Here's just a block diagram of the setup that we just showed you. You've got our switch sitting here in the middle. We've got the generator on this side. We've got the analyzer on this side. We have 20K ohm loads. We're going to be driving the signal here with a 2 volt RMS signal, and this signal here will be turned off. So we're going to be measuring crosstalk from L1 to R using the audio precision, and this will be driving and this will be off. And when you do that, you will get the curve that you see shown. One of the critical things is you need to have the chassis ground of the audio precision connected to the negative supply of your DC power source. This will keep any noise generated in the environment getting into the chassis ground of the audio precision. It gives it a path to a low impedance path to ground. So that connection is a critical connection, and the next critical connection is you have your audio precision on the channel that you're not driving connected, because the 20 ohms there is also critical in getting good isolation.
Well, going back to detail on that last statement, can you show on the block diagram of how the unused channel is showing a low impedance to ground?
Okay, you get feed through from the L1 channel that's driving through over here to the R channel, and with this 20 ohms connected up here, you get a parallel of 20 ohms in parallel with your 20K and parallel with the 100K, and that 20 ohms will take any feed through coming from L1 and give it a source away from your speaker load through the audio driver.
So that's where the high crosstalk performance comes from.
Correct. If you disconnect this, which we will do, we'll run the curve for you and show you that the crosstalk gets worse. So I'm going to come over here and disconnect this channel and let it float. You immediately
before you run, can you talk about this sweep?
This is the sweep with the channel that's not active connected, the 20 ohms. And you can see it goes from at 20 kilohertz, you're up at minus 20 dB, and it goes all the way down to 20 hertz of minus 50. With at 1 kilohertz, you're down at minus 140 dB. That's extremely low crosstalk, and shows that you get very little feed through to your load.
And this curve matches the data sheet.
And this curve matches the data sheet, yes.
Okay.
Now I'm going to append this. We now have the input floating here, so now when you run it, you'll see that it is going to be considerably less. And you can see the curve. And now you can see that you're only getting around anywhere from 65 dB, minus 70 to a little above 100, minus 100 dB. So this connection right here is critical in ensuring that you get the lowest possible crosstalk. And that concludes this video. Hopefully this will help the customer figure out why they're not getting the crosstalk that they see.